Okay, suppose that we're going to try to factor this polynomial. It has 4 terms. We might try grouping. Grouping doesn't work here. When we list its possible rational roots, we have the factors of 8 listed here and the factors of 6 listed here. So our possible roots are 1 over 1, 2 over 1, 4 over 1, 8 over 1, 1 over 2, 2 over 2 is 1, we already saw that. 4 over 2 is 2, we already saw that. 8 over 2 is 4, we already saw that. 1 over 3, 2 over 3, 4 over 3, 8 over 3, and then 1 over 6, 2 over 6 is 1/3, we already saw that. 4 over 6 is 2/3, we already saw that. 8 over 6 is 4/3, we already saw that. And then positive or negative version of each of these. And we have all of our possible rational roots. So that's what? 10 different numbers, positive or negative, 20 possibilities. That's a lot. Looking at the signs, we see that we have one sign change. We have one sign change, so we know we have one positive real root. Okay, well, we've got one positive real root. Let's try some positive numbers. And I like positive integers better than I like other positive numbers. So I might try all of the positive integers first. So I try 1, bring the 6 down. 6 times 1 is 6. 47 plus 6 is 53. 53 times 1 is 53, plus negative 9 is 44. Times 1 is 44, plus negative 8 is 36. Well, that escalated quickly. This is even worse, right? 6 times 2 is 12, plus 47 is 59. Times 2 is 118, plus negative 9 is 109. Times 2 is 218, plus negative 8 is 210. Now, this is not a technical term, but what we're seeing here I tend to call the coefficients blowing up. And with the larger potential roots, it just gets worse and worse. Here at this point, we're getting 6,000, which is real far from 0. None of them worked. And it actually turns out we could have known, without trying all of them, that none of them was going to work. By this theorem, if we have a positive number, and when we do the synthetic division by the corresponding coefficient, so we do the synthetic division to plug that in, every term in the quotient and also the remainder have the same sign, either all positive or all negative, though we usually work with positive leading coefficients, so they'll all be positive. Then that number is an upper bound on the roots of a polynomial. So what do I mean by an upper bound? Every root is less than or equal to that number. So in our example, notice 1 is positive, and all of these numbers have the same sign. That means that 1 is an upper bound. Every root is less than or equal to 1. 1 itself is not a root, so every root is a number less than 1. That means we didn't need to check 2, 4, or 8. We already knew those weren't going to be roots because they're bigger than 1. So we should either start to think about the negative roots if we really like integers, or try some of the fractions less than 1. I'm not going to finish factoring this in this video, just because it's going to be time consuming. Once we have the techniques for factoring fully, you are welcome to try to do more with this one.